And the only twist here is that we're going to be multiplying binomials. And the good news is that once I show you this, I think it will come back. Most of you got pretty good at this. We're not doing any factoring. Okay, not right now. We will get back to factoring, I believe, in chapter 12, but don't worry about that for now. The first thing I just want to remind you of is that to multiply binomials, we're going to be using FOIL. Oh, you guys are mad at FOIL too, huh? Poor little FOIL. We're going to be using FOIL. There's also, now let me see here, I'm going to pause for a second, and I'm just going to try to list so that you can look back in your notes if you need to. This comes back from chapter 5, and I don't even remember which, let's see, this would be, FOIL was this was lesson 5.4. So later on, if you need to look back at your notes, you can find these sections. Now the other things you're going to see, you can FOIL anything. But the other thing that you might see here, which you can use because it's a nice shortcut if you remember how to use it, is our special patterns. We had the difference of two perfect squares. And this was lesson 5.5. So again, I'll try to show you an example of each of these. I think there's an example of each. And hopefully it'll come back to you a little bit. And then we also had the special pattern, square of a binomial. I'll show you this one as well. This one was from lesson 5.6. So those numbers are just, if you see these patterns, if you forget about FOIL, if you want to refresh, where it doesn't have radicals, this is where you can look in your notes. Okay, way back to chapter 5. So let me start with just a basic one. And you guys maybe can tell me which one of these we want to use. 6 plus the square root of 11 times 6 minus the square root of 11. You can FOIL this. You can FOIL any pair of binomials and it will always work. But there's also these two special patterns. Anybody remember, do we have a pattern or should we just regular FOIL? Do we have a pattern here? CJ says yes. CJ, which pattern do you think we have? Because you're right, we do have a pattern.
Difference of two squares.
Good. And CJ, I'm impressed you remembered that. Maybe some of you, let me just show you guys. You don't need to write this down unless you want to. But the pattern for difference of two perfect squares was that we had the exact same thing in parentheses, except one has a plus and one has a minus. And when we do that, it's going to end up being a squared minus b squared for our answer. Because if we were to do FOIL, outer and inner, they'd be the exact same but with opposite signs and they would cancel each other out. So I'm going to do this one using the special pattern. Now, I'm going to do some of each. I will FOIL one, we'll do one of each. So this one, if you didn't recognize that it was the difference of two squares, when we get to FOIL, and we'll FOIL a regular one, I'll show you that it would work for this as well. Let's try to use the special pattern. According to this pattern, what is my A? Vincent? 6, right? So this says that the answer is going to be A squared. So we say, okay, what's 6 squared? Daniel?
36.
36. It's always a minus. It's always the difference of two perfect squares. So my B is the square root of 11. Now, I'm going to pause for a second and just write this down so that you can see what we're doing. We are doing the square root of 11 squared. Here's my B squared. You don't have to write it down this way first if you can keep track of what the answer is going to be. Otherwise, you write it down and maybe now you recognize, oh, the radical and the power of 2 cancel each other out, which means I'm left with 11. And in this case, 36 minus 11, oh, we could do that. 25. In a lot of these, you're going to be simplifying the answer down. There's no variables. Okay, it's just numbers. It just happens that the numbers have radicals. Okay, let's go back and do one that is just regular FOIL. Let me find one here if I can. Oh, there's not too many that are regular FOIL, but I'm going to just make one up here. All right, so let's say we have 5 times the square root of 5. Let's say minus 2 times 2 times the square root of 3 plus 6. I just want to review FOIL, because if you don't recognize the special patterns, you can FOIL it. If you can recognize the special patterns, you may not need to FOIL. But in case you want to know how to FOIL or how to remember how to do it, we'll use this. Remember, F for first means I take the first 2 that are in each. Now, let me write this down separately. This is starting to look a little crazy. Here is my F for FOIL. I've got 5 times the square root of 5 times, remember we're always multiplying these, 2 times the square root of 3. Okay, so at first I just wrote it down. We'll come back and simplify it later. Now, outer. We're going to end up following the signs that are here. When I do outer, it's 5 root 5 times 6, and this is a positive, so it's going to be a plus. Now again, I'm just starting by just writing it down. 5 root 5 times 6. Now, my inner, whoops, I started to write a plus, but that's a mistake, because when I do inner, I've got a negative times a positive, that makes a negative, so this would be a minus. And again, I'm just writing down what I get from each step here, 2 times 2 root 3. And my last, again, that means the last 2 in each parentheses. Negative 2 times 6 makes negative or minus 12. That's my L. So before we go in and simplify each of these brackets, any questions on what I did there? Right? First, outer, inner, last. Look familiar now? Maybe? Hopefully? Okay, let's go ahead and simplify. Remember that in a previous lesson, just a couple days ago, I forget which day, we did stuff like this where we were multiplying. And the idea was, this doesn't have to be alike. We can multiply anything. It's only with adding and subtracting, yesterday's lesson, where you have to look for like terms. In multiplying, all we're going to do is we're going to use a commutative property. And first we're going to take our whole numbers, 10, 5 times 2, and then I'll take my 2 radicals, and I'm just going to put them together, 5 times 3, 15. Now we'll come to my next. Again, we could do the commutative property. I'm going to first multiply the 5 times 6, and I get 30 times the square root of 5. Next, I'm going to do my I. That's going to be a minus. If I do, again, the commutative property, 2 times 2 is 4, times the square root of 3. Now, I could try to go, oh, 5 times 3, but that's not going to help me, even though I have a 5 and a 3 here. You only need to factor the radical if it has perfect square factors, and 15 doesn't. So guess what? We'd be done here. It's long. We can't combine anything. It's not very pretty. But that's all you have to do is just go carefully. First, outer, inner, and last. If it helps to write them down each time, you might want to do that. Because if you're trying to do this all mental math, most people will end up making mistakes, even myself. I mean, 2 times 6, of course, that's mental math. But everything else, I'm going to suggest you write it down, unless you really think you can do it without having to write it down. Now, we need to do another one with a pattern. Let's do the mistake a lot of people make on this is they square this 3 and they square the root 5 and think they're done. But that's not how it goes. First of all, I will just tell you that this is the square of a binomial from lesson 5-6. What that means is that the whole binomial is squared. Now, first of all, if you want to FOIL this, here's why you can't just square the 3 and the root 5. That would be wrong. Because technically, this is 3 plus the square root of 5 times 3 plus the square root of 5, right? It's the exact same thing times itself twice. It's not the difference of perfect squares. If you do outer and inner, they will not cancel out. They will combine because they're alike, but they'll still be there. So you could FOIL this, and if you want me to, I'll ask at the end. If you want me to, I can FOIL it. But if not, if you want to use the shortcut, I'd like to first remind you of the shortcut. A plus B squared equals A squared plus 2AB plus b squared. Now, since we're writing the formula down, let's just put the other one so you have it. It's the exact same thing, except it's a minus, which means both parentheses would have a minus instead of both being a plus. And the only difference in the formula is that it becomes a squared minus 2ab, but still a plus b squared at the end. Now, technically, the right side here, I didn't need the parentheses, but they're already there, so we'll just leave them. So we're going to get to use the first pattern. It's got the plus, so we got to use the one with the plus. My a is the 3, my b is the root 5. We're going to write it following this pattern here on the right. So the first thing I need to do is square my a. What do I get when I square my a? Diego? 9. 3 times 3, put it down here, 9. There's my a squared. Now I know it's going to be all pluses. I like to do the easiest part next, which is b squared. If I square root 5 times root 5, what do I get? Brian? 5. Remember, because that's this. Square root of 5 squared and the power of 2, or the radical and the power of 2 cancel out. Okay, now in the middle, 2 times my a times my b. And I have to simplify that middle part. All of this multiplication has to happen before addition, right? Think of PEMDAS. So I'm just going to keep my 9 for a minute. I'm going to keep my 5 at the end. And I'm just going to multiply in here. 2 times 3 is 6 times the square root of 5. 6 times the square root of 5. Can I simplify anything else while I'm here? Izzy? Yeah, 9 plus 5, 14, plus 6 times the square root of 5. Can I combine these two? This goes to yesterday's lesson, adding with radicals. Okay, good, I see thumbs down. No, we can't. This one has a root 5, this one does not. We're done. Now, you could have foiled this. Let me just point out, you don't have to, I'm not going to go all the way through foiling it, but let me just show you what you'd get if you did, and if you don't want to write it down because you plan to use the patterns, that's fine, you can just watch. If we were to foil this, first, 3 times 3, 9. Outer, 3 times root 5. Inner, 3 times root 5. Last, root 5 times root 5. If you are foiling, remember your outer and your inner, the two middle ones, should always be like terms. And so they should combine, and we get back to what we just did. Same answer. Okay, so you can choose to foil all of these if you want to. Otherwise, I think almost all, if not all of the homework problems, use the special patterns. So I'm going to do just one more. We're going to do this pattern here. I need to take it off the screen so I can start a new page, but it's going to be this one. So I'm going to rewrite that. You don't need to rewrite it because you have it on your paper, but I want to have it showing here. Oops, 2, 3. Okay, so we're going to use this pattern, and this one is just going to be one step more complicated because there's going to be radicals on both of the numbers. That's the only difference. The last one only had a radical on one. Here they both have a radical. Okay, now again, you could foil this. If you foil it, write it out side by side, two of them, and do first, outer, inner, last. If we're going to use the pattern, though, let's try it. A squared. Oh dear, this is going to be more complicated. Here's what I want you to do on one like this. I want you to first just write it down. Here's my A squared. Because we're going to have to come back and really be careful as we work with this. It's going to be a minus, that's the pattern, 2 times my A, 2 root 3, times my B, 5 root 7. Now this is all, I'm going to just put it in parentheses. You don't need to, but I think it kind of helps to separate it out because there's a lot going on here. Here's my 2 times A times B, plus, always a plus, B squared. Now again, since this one has more than just the radical, I'm just going to write it down first to make sure I don't forget anything. I was running out of room there, but 5 root 7 squared. Everybody okay so far? We're just writing it down, following the pattern. Okay. Now we just have to be careful. Anything to the power of 2 in parentheses means everything gets raised to the power of 2. So what I get here, and I'm going to keep the parentheses for each level just to start, 2 times 2 is 4. And so I squared the 2. What happens when I square root 3? What do I get, Diego? 3. We'll come back and simplify this in our last step. All right, this middle one with all this stuff going on. Remember, we can multiply in any order. So all we're going to do is we're going to take all the whole numbers. 2 times 2 is 4. 4 times 5 is 20. I'm going to take my 2 radicals, the 3 and the 7, and I'm going to put them together. 21. This is as hard as it will get. Again, we're still using the pattern, but you could FOIL it and you'd get it. It would be just as difficult. Next, I have to square the 5, 25, and the square root of 7 squared. Again, the radical and the exponent cancel out, leaving just the 7. And now all I have to come back and do is simplify each parentheses. Here's 12 minus 20, root 21, plus 175. So again, I'm going to suggest that you do it the way I'm doing it, where you just first write down, here's what I'm squaring. Because if you forget to square the 2 to get this 4, then you have the wrong answer. If you forget to square the 5, if you forget any piece, you get the wrong answer. So I'm going to suggest you write it down. There won't be too many that are this hard. I can still do combining like terms. I've got positive 12 and positive 175 to make 187 minus 20, root 21. And we're done there. We can't combine those because it's subtracting, and then you have to have like terms. Not so bad, I hope. All right, so that's it. Remember, for any of these, if you don't want to use the patterns, FOIL it, write it out side by side, first, outer, inner, last. This will be written exercises. And again, we're going to do 2 through 18. Let me see, is that, yes, 2 through 18 even.